Okay, this is good application of a quadratic. It has an equation here that says it's the equation that shows that after a certain number of seconds, t, when a rocket is fired, it will tell us the height of what the rocket is. So if you give it a t value and you square it, multiply it by negative 4.9, add 355 times whatever t is, and then add 248, then what comes out of this function is the height. So the height is a function of the time of the rocket. So what I like to do on this type of problem is, first of all, enter it into my calculator. So if you hit your y equal key and then type that equation in, you'll see that I've got it typed in already. Make sure that you use the negative key and not the subtract key on the 4.9. Of course, the input is t, but on your calculator you're going to be using x, and then the output's going to be y. Now what I'd like to do at this point is to graph this function, but if I don't set up my, my window properly, if I just hit the graph key, you're going to get just strange things that occur. Here I'm seeing just like a vertical line, so I really have to think about where I want my window. And what would help with this is to look at the table of values, and before I do that I'm going to set up my table. So I'm going to go second, and then above the window is a table setup. And I'm just going to tell it that I want to start at 0 seconds, that's my input, and then go in increments of 1. And then you can set these other two values to auto. And now if I go to table, which is above the graph, so I hit second table, I can start to understand what's happening with this function. You can see that at 0 seconds it's 240 feet off the ground, and sure enough, if I go over to my function here, I can see that that's the c value of the function, 248. So if I put a 0 in, the rocket's obviously being shot on some hill or something that's about 248 feet, I guess this is in meters above the ground. And then if I scroll down, I can see what happens, how high the rocket is after so many seconds. So if I keep scrolling down, I can almost answer these questions about how high is the rocket going to get and when will it splash down just by scrolling down on my table. Looks to me like the rocket keeps getting higher and higher. It's up to 4,000 feet. I'll just keep going here. At some point it's gonna kind of max out and then start coming back down again. It looks to me like it's still climbing. And sure enough, still climbing. Whoops, looks like I passed it somewhere here. Looks like the values are starting to come back down again. So somewhere, right around 37 seconds or so, it looks to me like it maxes out. Yeah, around 36 seconds. Now if I wanted to see when it's going to splash down, I can also keep going until I see it go down to 0. It'll actually go below 0. Right in here somewhere, so around 73 seconds or so. But I don't want to just guess. I want to actually graph this function. So when I set up my my maximum and my minimum on my x's and y's, I can look at the table. See, this function now keeps going, but I can see that I don't need to go more than about 75 seconds, and I'll see that it splashes down. I probably want to go a little bit past that. And then likewise on the other end, notice that the rocket gets up to about 6,000 feet or so, a little over almost 7,000 feet, I guess. So that's going to become important for the y value. But obviously, I don't have to go below 0 seconds because that would be going backwards in time. But just to see my y-axis, I might want to go backwards a little bit. So now I'm ready to set up my window. So for my seconds, let's start at, maybe negative 10 seconds would be good, I guess. And then it looked to me like when it splashes down, it's about 70 some seconds. Let's go up to, 90 seconds. Okay. The scales, we can just leave those as 1. Now for the height of the rocket, well, it doesn't really go below ground, and it looked like it went up to about 7,000 feet. Let me go, 1,000 below though, because I kind of like to see my x-axis. And for the height of it, even though it only goes up to 7,000 or so, I'm going to go up to 8,000 or even 9,000 would be good. So now when I graph it, I should be able to see this function. There it is. Okay, now I can use my calculator to calculate the answer to both of these, which I'm going to do, but I also want to talk about how you would do it by hand. Obviously, where the rocket splashes down is this 0 or x-intercept on the right-hand side. So to find the zeros of a quadratic formula, you use the entire quadratic formula. So I've got the steps shown down here on the right-hand side. So if I were to do the quadratic formula, I would end up with two different answers, one of which doesn't make any sense, negative, roughly a half a second. That's where the rocket is on the left-hand side here. Now I want to show you how to plug this in, so you have to be real careful if you're doing this by hand. So let me clear this out. Let's see if I can get this to clear. Okay, you have to be careful with parentheses here. We have to put parentheses around the numerator. So we've got left parenthesis, negative 355, plus and minus. I'm going to do the minus one because that's the one that gives me the answer that makes sense. The square root, so I have to get the square root in here. On my calculator, it puts one parenthesis in there already. So the square root of 355 squared, subtract 4ac, so 4 times negative 4.9 times 248. Now I need a right parenthesis there to tell it that I'm done taking the square root, and then another right parenthesis that tells me that I'm done with my numerator. Now I want to divide by, and again I want to put the denominator in parentheses, and that's 2 times negative 4.9 parentheses. And when I press enter, I get about, the rocket's going to splash down in about 73.141, let's call it. You want to put a few decimal places in there. And that looked like about what my table was saying too, is that about in 73 seconds it was going to splash down. So there's the answer for the first part. Now if you wanted to know when the rocket's going to reach its maximum height, that you're looking for the vertex. So what you could do is take the beam of the quadratic formula, so that part right there, and I went ahead and did that work. So I took the opposite of b all over 2a, and I got 36.2244. Now that's when the rocket's going to reach its peak, but it wants to know how high will the rocket be. So the next step would be is I would have to take that value 36 seconds. Actually, I'd probably have to record it with a few decimal places. And I'd have to plug it back into my equation and then come up with the height of it. So I'll go ahead and leave that to you to do. I want to go ahead and use my calculator to find these values. So let's see. Let me go ahead and clear and get my graph back on there. Let's see, if I want to know when the rocket's going to splash down, that would be the zeros. So I go second, calculate 0. Enter. It's going to ask me 3 questions, left bound, right bound. So I'm heading over here to the one on the right because that's where the rocket's going to splash down. So I want to get somewhere to the left of it, press enter. And then I need to get to the right of it, which means to kind of go down below a little bit. And then press enter. And then when it says guess, you just move the cursor back about to that point and press enter. And sure enough, it says 73.141 seconds. And that jives with my table. And that also jives with what I calculated by hand. To look to see when the rocket is going to reach its maximum height, or I guess it's asking how high the rocket's going to be, I go second, calculate, look for the maximum point. Let's see, I want maximum. Left boundary, so I have to keep hitting the left arrow here until I get to the left of the maximum up there, the peak somewhere, a little bit more. There we go. Enter. Then I move to the right of it and mark that, and then get close to it. When I mark it, my calculator shows me, sure enough, at 36.2244 seconds, and that's what I calculated by hand. The rocket will be at its maximum height about 6677.8469. And again, that was what I was estimating when I did my table. So the main thing is, after you put your equation in, you really have to think about, if you're going to do this by graphing, you really have to think about your window. So look at your table And from your table, you can see the seconds that go by, and you want to search to see how high the rocket goes. That gives you an idea for what your maximum Y should be, and we saw that it was, sure enough, it was about 7,000 feet. And then you can also tell about when the rocket's going to splash down, and we saw that was at about 73 seconds as well. Now you could just read these values off the table, but see, the table is not nearly as accurate. That's why they want you to put in a few decimal places. They want to know that you just didn't type in 73 there and guess. You actually are calculating it by either doing it by hand or using the calculate feature of your calculator. All right, I hope that helps.